What if, one day, the headlines weren't about politics or celebrities, but about an alert from NASA that sent a chill down the spine of every person on the planet? Imagine waking up to the news. A black hole, a real one, has been detected on a direct collision course with our solar system. It's not science fiction, it's our new reality. The initial reports would be chaotic, a flood of data and panicked speculation. Astronomers worldwide would scramble to verify the findings, their telescopes all pointing to a single, terrifying spot in the void. What would we even do? Could Earth survive such an encounter? Or would everything we've ever known, every memory, every achievement, every last trace of humanity, simply vanish in the blink of an eye? This isn't just a question of survival, it's a question of existence itself. Before we dive into the terrifying timeline of what would happen next, let's quickly get on the same page about what a black hole actually is. Forget the Hollywood wormholes and cosmic shortcuts for a moment. In the simplest terms, a black hole is a region of space-time where gravity is so incredibly strong that nothing, not even light, the fastest thing in the universe, can escape. Think of it as the universe's ultimate one-way street. So, how does something this extreme come into being? It all starts with a star, but not just any star, like our sun. We're talking about a supergiant, a star at least 20 to 30 times more massive than our own. Throughout its life, this colossal star burns through its nuclear fuel, creating a delicate balance. The outward push from the nuclear fusion in its core is constantly fighting against the inward pull of its own immense gravity. It's a cosmic arm wrestle that lasts for millions of years. But eventually, the star runs out of fuel, the outward push stops, and when it does, gravity wins, and it wins catastrophically. In a fraction of a second, the star's core collapses under its own weight. This collapse is so violent, so unbelievably rapid, that it triggers a titanic explosion known as a supernova. The outer layers of the star are blasted out into space, seeding the cosmos with heavy elements that will one day form new stars, planets, and maybe even life. But what's left behind is the real monster. The core continues to collapse in on itself, crushing all that mass into an infinitesimally small point. This point is called the singularity. Now, the singularity is a place where our understanding of physics completely breaks down. It's a point of infinite density and zero volume. Imagine taking something with the mass of millions of Earths and squeezing it into a space smaller than the period at the end of this sentence. That's the kind of mind-bending physics we're dealing with. It's the heart of the black hole, where the laws of nature as we know them cease to apply. Surrounding this singularity is a boundary known as the event horizon. This isn't a physical surface you could touch. It's more like a point of no return. The point of no return is a perfect description. Once you cross the event horizon, the escape velocity, the speed you need to escape the gravitational pull, becomes greater than the speed of light. Since nothing can travel faster than light, anything that crosses this threshold is trapped forever. It's the ultimate cosmic prison. From outside the event horizon, you wouldn't see the singularity itself. You just see a perfect sphere of blackness, a silhouette against the stars, because all light that enters is absorbed, and no light from within can get out. So, when we say a black hole is heading for us, we're not talking about a solid object like an asteroid. We're talking about a fundamental distortion of space and time itself, a gravitational well so deep that it devours reality. The danger isn't just from a direct impact. Its mere presence warps the fabric of the cosmos around it. The real terror begins long before the black hole itself arrives. The first signs wouldn't be visible to the naked eye. They'd be subtle. Gravitational whispers detected only by our most sensitive instruments. Initially, the discovery would likely be made by gravitational wave observatories, like LIGO or Virgo. These incredible facilities don't use light. They listen for ripples in spacetime itself, caused by cataclysmic events like the merging of two black holes. If a lone black hole were cruising through our galactic neighborhood, it would still disturb the spacetime around it. These observatories might pick up a faint, persistent hum, a gravitational signature that doesn't match any known phenomenon. It would be a mystery at first, a puzzle for astrophysicists to solve. Simultaneously, astronomers studying the outer reaches of our solar system would notice something strange. The orbits of distant objects in the Kuiper Belt and the Oort cloud, the icy debris field that surrounds our solar system, would start to go haywire. Comets and dwarf planets that have been on stable, predictable paths for billions of years would suddenly be nudged, their trajectories altered as if by an unseen hand. The gravitational influence of a massive, invisible object would be the only logical explanation. This would be our canary in the coal mine. The tiny, far-flung members of our solar family would be the first to signal the impending doom. As the black hole drew closer, these gravitational effects would become more and more pronounced. We'd see it in the dance of our own planets. The orbits of Neptune and Uranus would begin to stretch and warp. The precise, clockwork motion of our solar system, governed by the sun's gravity for 4.5 billion years, would start to unravel. Imagine trying to run on a trampoline while someone much heavier starts jumping right next to you. The ground beneath your feet becomes unstable and chaotic. That's what would happen to the orbits of the outer planets. They would be pulled and tugged by this new, dominant source of gravity. Then would come the visual evidence. As the black hole enters the Oort cloud, its immense gravity would act like a cosmic slingshot, flinging a torrential storm of comets and asteroids toward the inner solar system. Our skies, normally serene, would light up with a constant, terrifying meteor shower. Not the beautiful, fleeting shooting stars we wish upon, but a relentless bombardment of celestial bodies, some the size of mountains or even small cities. Earth would become a cosmic shooting gallery. Our planetary defense systems, designed to track a handful of potentially hazardous asteroids, would be completely overwhelmed. It would be a rain of fire and destruction, a prelude to the main event. At this point, the black hole itself would still be invisible, but its effects would be undeniable. The world would be in a state of panic, yet unified by a single, terrifying focus. All of our resources, all of our scientific minds, would be dedicated to one goal: understanding and somehow surviving the approaching abyss. The greatest minds from every nation would collaborate, sharing data and theories in a desperate race against time. The question on everyone's lips would be, how long do we have? And is there anything at all we can do? Imagine this, deep within the sterile, quiet rooms of a NASA control center, or perhaps at the European Southern Observatory high in the Atacama Desert. An astronomer squints at a screen. Data is flowing in from the James Webb Space Telescope, a torrent of information from the deepest, darkest corners of the universe. For weeks, they've been observing a distant galaxy, cataloging its stars, mapping its structure. But something's off. There's a subtle, almost imperceptible wobble in the light from a cluster of stars, billions of light years away. It's a distortion, a gravitational lens, where the gravity of a massive object bends the light from whatever is behind it, like a cosmic magnifying glass. This isn't unusual. They see gravitational lensing all the time. It's one of the ways we confirm the existence of dark matter and study faraway galaxies. They log it, classify it as a probable rogue planet, or maybe a brown dwarf, something massive, but too dim to see directly. They assign it a designation, a string of letters and numbers, and move on. But a week later, a junior researcher, running a routine follow-up, flags the data. The lens hasn't just magnified the light, it has shifted. The team pulls up the previous week's observations, and a cold realization begins to dawn. This object, this gravitational anomaly, isn't orbiting a distant star. It isn't drifting aimlessly through the intergalactic void. It's moving with a purpose. It's moving fast, and it's moving ... towards us. Panic, at first, is a quiet, controlled affair. Double checks are run. Other telescopes are pointed at that same patch of empty sky. The data is irrefutable. The distortion is growing. At first, scientists thought it was just another distant object, a curiosity for academic papers, until they realized it was moving. A frantic calculation is made, plotting its trajectory. The results are impossible. They check them again and again. The conclusion remains the same. The invisible object, a black hole, is on a direct course for our solar system. The news isn't released to the public. Not yet. How do you tell the world that a silent, invisible monster is coming to swallow the sky. Years pass. For most of humanity, life continues unchanged. We work, we love, we dream. But for a select few, every sunrise is a reminder of the clock ticking down. The black hole is now at the edge of the Oort cloud, the outermost boundary of our solar system. It's still trillions of kilometers away, an incomprehensible distance. We can't see it, we can't feel it, but we can see its effects. The first harbingers are subtle, only detectable by the most sensitive instruments. The orbits of the farthest dwarf planets, like Sedna and Eris, begin to wobble. Their long, lazy loops around the sun start to stretch, pulled by a new, unseen gravitational master. On Earth, astronomers notice that comets, once predictable visitors, are appearing from unexpected directions. These icy wanderers, nudged from their ancient orbits in the Oort cloud, begin to rain down into the inner solar system in greater numbers. The night sky becomes an unpredictable shooting gallery. Then, the first visible sign appears. Not for scientists, but for anyone who looks up. The familiar constellations, the patterns that have guided humanity for millennia, begin to drift. It's almost imperceptible at first, like a smudge on a photograph. Stars near the apparent location of the black hole seem to stretch and smear. The Big Dipper's handle begins to curve unnaturally. Orion's belt looks warped. This isn't the familiar, gentle rotation of the night sky. This is the very fabric of space-time being twisted. The silent apocalypse has begun. As the black hole crosses the threshold of the Kuiper belt, just beyond Neptune, its gravitational influence becomes a monstrous, tensible force. Neptune and Uranus, our distant ice giants, are the first to truly feel its pull. Their orbits, once as reliable as clockwork, become erratic. Their tugged-violencia, their orbital paths, elongating, threatening to fling them out of the solar system entirely, or pull them inward on a collision course with their neighbors. On Earth, the consequences become more direct. The influx of comets and asteroids from the disturbed Kuiper belt intensifies. Meteor showers are no longer a beautiful, rare spectacle. They are a constant, terrifying threat. Governments scramble to build defense systems, but it's like trying to stop a tidal wave with a bucket. Cities experience impacts. The global news cycle, once focused on politics and economics, is now a 24/7 disaster watch. The gravitational pull begins to affect the entire architecture of our solar system. Imagine our solar system not as a static model, but as a delicate mobile, perfectly balanced. Now, a giant, invisible hand is grabbing one side and shaking it. Saturn's magnificent rings, composed of trillions of ice particles held in a perfect gravitational embrace, begin to clumps form, and streams of ice and rock are torn away, creating new, chaotic streams of debris. Jupiter, the great protector of the inner solar system, finds itself in a gravitational tug of its immense gravity, which normally shields Earth by capturing or deflecting inbound asteroids, is now pitted against the even more powerful pull of the black hole. Jupiter itself is pulled, its orbit shifting, and in the process, its own family of moons is thrown into disarray. Moons like Europa and Ganymede are ripped from their orbits. Some sent careening into Jupiter, others flung out into the darkness. This cosmic chaos sends gravitational ripples inward. The asteroid belt between Mars and Jupiter, a relatively stable region for billions of years, becomes a blender. Asteroids are sent flying in all directions. Mars is pelted relentlessly, its thin atmosphere stripped away by the barrage, and then the pull reaches Earth. It's not a sudden jolt, but a slow, inexorable stretch. The first effect is on our most precise measurements. GPS systems fail. The network of satellites we rely on for communication and navigation can no longer hold their precise orbits. They drift, they tumble, and one by one, they go dark. Global communication breaks down. The moon, our constant companion, begins to drift away. Its orbit elongates, causing tidal forces on Earth to become wild and unpredictable. One day, the tides are monstrous. Global tsunamis that reshape coastlines and swallow cities. The next, the oceans are eerily calm, the water pulled away from the shore. The very length of our day begins to change. The Earth's rotation wobbles. This tidal flexing of the planet's crust reawakens dormant volcanoes and creates earthquakes in places that have never known them. The ground beneath our feet is no longer stable. The sky is a place of terror. The sun still rises, but the view is alien. The starlight is no longer a collection of points, but a swirling vortex of light, all being pulled towards an invisible maw. During the day, the sky is still blue, but the light itself feels different, heavy. We can't see the black hole. Not yet, but we feel Italiano. We feel it in the trembling of the earth, in the raging of the seas, and in the profound, bone-deep certainty that our world, our home, is being unmade, piece by piece, before our very eyes. The silent, slow-motion apocalypse is entering its final, terrifying phase. As the black hole draws nearer, its immense gravity begins to wage war on our planet. This is phase 2. Distortion and chaos. The final days of Earth as we know it. The first casualties are the oceans. Massive tidal forces, trillions of times stronger than the moon's, pulled the water from its basins. A global wall of water, miles high, surges across continents, swallowing cities whole. The ground beneath our feet is no longer solid. The planet's crust groans and fractures under the strain, triggering earthquakes of unimaginable magnitude. Mountains crumble, and the very continents begin to shift and tear apart. Look up at the sky. It's no longer the familiar blue expanse. The black hole's gravity is so intense that it bends the fabric of space-time itself. Starlight from distant galaxies twists and smears into surreal, kaleidoscopic patterns. The sun, our life-giving star, appears warped, its light stretched into a bizarre arc around the growing abyss. The atmosphere, our protective blanket, is stripped away, layer by layer, pulled into the insatiable void. Our moon, a faithful companion for eons, meets a violent end. The tidal forces overwhelm its own gravity, and it shatters into a spectacular ring of debris, a final, fleeting crown for a dying Earth. We are witnessing the deconstruction of our solar system, a celestial ballet of destruction. And then, the most profound and terrifying change begins. Time itself starts to unravel. For an observer watching from a safe distance, our final moments would appear to stretch into an eternity, frozen on the event horizon. But for us, on Earth, time would accelerate wildly, a chaotic cascade of moments as we plunge toward the singularity. Past, present, and future blur into an incomprehensible stream. Even time itself would begin to fall apart. The sky is no longer a sky. It's a swirling vortex of distorted light and raw cosmic energy. The horizon has vanished, replaced by the encroaching darkness of the event horizon. The Earth, our beautiful blue marble, is now a molten, misshapen sphere, stretched and distorted like taffy in a cosmic pool. This process is called spaghetti. Every atom of our planet, every rock, every tree, and every living thing is being elongated into a thin stream of matter, flowing like a river into the black hole. We see the final, silent scream of our world as it crosses the point of no return. The light from our sun, captured in its final journey, bends around the black hole in a breathtaking photon ring, a halo of fire around the ultimate darkness. And then, nothing. The screen fades to black. Silence. The Earth is gone. Is this the end? Is this the final, absolute conclusion to the story of humanity? Perhaps not. Some theories suggest that falling into a black hole might not be an end, but a transformation. What if it's not a death sentence, but a doorway? This is where the known laws of physics break down and speculation takes flight. Could the singularity at the heart of a black hole be a connection point, a wormhole, to another part of our own universe, or even to another universe entirely? Imagine, for a moment, that the matter of our world, broken down into its most fundamental particles, emerges on the other side. Not as Earth, not as us, but as the raw material for a new creation. Another fascinating idea is that the singularity could trigger a new Big Bang. Our universe, compressed into an infinitely dense point, could rebound, exploding outward to form a new cosmos with its own stars, its own galaxies, and perhaps its own life. Our end could be the genesis of a daughter universe, In this cosmic cycle of death and rebirth, our legacy wouldn't be erased, but rather recycled into something entirely new. So, as the last remnants of our world are consumed by the abyss, we are left with a haunting question. Would that be our end? Or the beginning of something new? What do you think lies on the other side of a black hole? A new universe? Another dimension? Or simply the end? Let me know your most mind-bending theories in the comments below. Thank you for joining me on this journey to the edge of existence. If you enjoyed this exploration of the cosmos, do not forget to like this video and subscribe to the channel for more content that pushes the boundaries of imagination. Stay curious, and I'll see you in the next one.